Hi, this is Phil Morton, January 2019, a video presentation, System 5050, density of the ensemble sound, introduction to the topic, and we'll be coming across concepts of density index or sound mass. Unlike what it says there, there's no research feedback. This is just an introduction. It comes with the assumed knowledge that you have knowledge of System 5050, what it actually is, and preferably experience of using it. If you have experience of using it, it's not compulsory to watch this video to understand the concepts. You can still participate in any event quite happily without actually reading these notes. How to use the video. During the video you'll be invited to pause the screen because there'll be some text on the screen. I'm not going to read all the way through the text, so you're advised to pause, read it, have a little think, and then move on when you're ready to do so. Plus, this presentation is a playlist, so there's several other videos less than a minute long that follow on that are just on related topics to System 5050 project. So let us start, and let us start with the three considerations. So here we have the three considerations, and they are: in any ensemble performance, there's the number of players, the ratio of free play to tacit, and duration of the piece. So have a little pause of the screen, read that again, have a think. When you're happy to move on, move on. So here we have an example of a performance of 5050. Pause the screen and read the notes. Being very simplistic, I want you to consider that an ensemble of 5 players on average will play less sound mass music than 10 players. There's more to it than that, but that's, if you can just bear with me and hold that concept, and let's move on. If we're going to have a density index, or what Martin Hackett suggested, sound mass evaluation of a piece, I'm going to propose it's useful to have a value which is 1. So that becomes like a benchmark. So I suggest you pause the screen and read the notes. Summarising this up, the benchmark is one person playing continuously for the whole duration of one piece on their own. One person plays for 10 minutes, it's 10 minutes long. If you do the maths there, you get a value of 1. That is the proposed benchmark or reference point. And now I'm going to move on to other examples. So here we have an example with 10 players. Please pause the screen and read the notes. Have a think about the mathematics there. Now here we are with the same example but with 5 players. I invite you to pause the screen and read the notes. So if you've made sense of that, we can now compare and contrast the two. I'll just minimize the screens. So what we can now see is we've got 2 examples where everything's the same, except the numbers are different in the second example. In fact, the numbers are half the numbers. It's 5 players instead of 10, and we end up with a value, an output value, which is half, which kind of makes me think I might be on the right track from a mathematical point of view. So this is about maths, not about music. So have a think about that, and we'll come back to it later, and I'm going to move on. I'm just let the screen, suggest you pause the screen, and when you're ready to move on, press play. So so I'm just summarise. This is just an introduction to what's called density index or sound mess. It's a very simplistic introduction. Back to the beginning, there's 3 factors to consider: duration of piece, ratio of the clock settings, that is the free play to tacit time, and the number of players. And there's a question there, and can we manage outcomes, return to them, or is this a tool to help us develop the project, evaluate our experiences, so on and so forth? I'm just going to pause the screen. So limitations of this summary, it's very simple. The logic of density index should equal 1, and that's our benchmark. Has not been tested, but that's what I'm offering. Known complications, consequences, considerations, further testimonies of its application have been left out. A lot has been left out. This is just a simple introduction. These topics will be covered later. And just before I end, I'll just suggested homework. If you wish to, you could look at these formulations here and just change all the numbers and the settings and speculate in your head what would be the different outcomes. That's just a suggestion, and that's homework and to be continued. And what follows now are some information videos under a minute long that just relate to this project. Thanks for watching, and as I say, this will be continued. Bye for now.